Research work BioZashchita Biometric Voice Authentication System. The system involves recognizing the user and logging into any system by a voice phrase password. In addition to the password, the biometric features of a person's voice are taken into account. This layout presents their own alien classification. That is, the system recognizes a trained user and doesn't let any other person to pass, even if he knows the passphrase. The chances of a skip error depends on many factors. See my GitHub doc file for details. So let's train the system and pass the authentication. For example, let there be a passphrase. This is Dmitry Kalashnokov, please let me through. You must say the phrase about 12 times. This is Dmitry Kalashnokov, please let me through. The images for training have been formed. The biometric parameters themselves can be viewed, if desired, by clicking on this button. We start training the network and go to the authentication window. We say the phrase again. This is Dmitry Kalashnikov, please let me through. The system lets us through by verifying the password and biometric parameters. Any other person will be able to pass through authentication even if he knows the password.
This is Dmitry Kalashnikov, let me through.
The probability of passage ranges from 10 to the -3rd power and below. The system can operate with noise, for example. This is Dmitry Kalashnikov, please let me through. The problem of working in noise is solved in 3 ways, which can be combined. Cardioid narrow beam microphone, algorithms for training a stationarity noise model, an example as a Reaper, and third, take the period of the pitch frequency as a basis for biometric parameters. I researched this in my dissertation, but then the user will have to remember the intonation with which he pronounces the passphrases. The speech-to-text translation system is implemented using the WOSC-CALDI algorithms. The project was completely written by me. Biometric voice identification system. Voice recognition system, but without a passphrase. That is, the phrase can be any. Stable recognition will require about 40 phrases in a training set of 15-20 seconds of continuous speech. On a dark desert highway, cool wind in my hair, warm smell the eucalyptus rising up through the air. Up ahead in the distance I heard a shimmering light. My head grew heavy and my sight grew dim. I had to stop for the night. Welcome to the Hotel California. Please allow access, it's me, Dmitry.
Please allow access. It's me, Dmitry.
Experimental design work Promtech Voice. Here is a layout for offline speech-to-text translation. I did work on using the Cameo Sphinx library on microcontrollers. I was also engaged in the program of adaptation of the Sphinx model for users.
Активировать голосовое управление. Открыть блокнот. Ввести пароль.
Experimental design work index MM. In this work I present a layout of a recognition of the translation written into text. In this work, a program was possible to scan a document and translate it into text. My colleagues and I trained a neural network model for Russian and English letters. The classification of each symbol combinations was automatically carried out, and sentences were formed on the algorithms of conditional probability written by me. As a result, the scanned JPEG file was decrypted with accuracy of 93%. The program has been tested on 350 pages of different text from different people. Research work construction of biometric neural network authentication tool based on medium harmonic neurons. The GitHub shows a program for recognizing a person by handwriting, which implements a neural network that I wrote in 2020. Similar to the voice recognition system, a password is set here. And biometric indicators are compared. A total of 416 handwriting parameters are used. In the training window, add the images of our signature and submit for training. The handwriting recognition stability window is displayed and we proceed to the testing stage, during which authentication takes place. Okay, the program recognized me and did not let outsider in and gave out the Hamming measure, that is, measure of mismatch in bits. I encoded the biometric parameters in the program with a 250-bit key, which advises 32 characters. Not the coolest biometrics, but it can be used as a part of any system. The layout was made in our team. I implemented a neural network which is currently being registered as a guest. The algorithm of neural network will take about half an hour. If you are interested, I can tell you about it either in a video message or send a doc file. Experimental design work Lekar-P. As a result of this work, such token was implemented by me and people from my laboratory. Software and hardware in the form of a USB device for verifying and generating an electronic signature with biometric identity confirmation. In this work I wrote a backend and specifically participated in the development of a neural network of the GHOST R526333 standard. This is a linear neural network which consists of 256 neurons. At the input of each neuron there are 24 inputs of biometric parameters. The meaning of this standard was that it was necessary to obtain a biometric key, which is encrypted by the user's biometrics. As a result, the device we have implemented was intended for use in the systems of personal data depersonalization of medical institutes, electronic documents, management systems, trades, and services. Research work 3D face. With the team I developed software for human recognition based on 3D face image. I collected a database of biometric images that was engaged in parsing photos. Development of a highly intelligent noise suppression tool for an intercom voice lock. My job was a development of noise filtering algorithms for using a voice biometric authentication system. I developed algorithms for the selection of biometric parameters of the voice that don't depend on external non-speech noise. As a result was designed an intercom with voice authentication. Research work as T-support. Research and implementation of a demonstration model for finding molecular hacking signals received from an oscilloscope using various types of neural networks. To solve these problems, algorithms of a number of supervised learning neural networks were implemented in one model. I will demonstrate how to find a bad signal after training two classes of signals. We add two classes 1 and zeros to the software layout. We select a neural network and run it. When testing any signal, we get the probability of belonging to the class. The work used linear, quadratic, and deep neural networks of the TensorFlow type. Research work Leek. Development of algorithms for compression and speech synthesis to create a new class of biometric vocoders. Experimental design work Promtech Voice. Implementation and adaptation of the voice model of speech translation on laryngophones for a limited number of people, using KMU Sphinx. Experimental design work BioZamok. Construction of a test biometric lock using 2D face, voice, finger technologies. I have adapted my biometric voice authentication system to a biometric lock. Registration of software products. On the state registration of the computer program, means of neural network biometric voice recognition at a noise level above the signal level.